Good morning, Sarah.
Good morning.
Sarah, you were moving at a pretty good clip when I passed you on our jog the other 2 nights ago.
Oh, yeah.
Do you jog on a team, or you just jog for fun?
Just for fun.
Yeah?
Yeah, it's been really nice outside lately. It's been outside before it's too cold and I go to the gym.
It's been wonderful. It's really been wonderful. I have a colleague. Yeah. I have a colleague who does really long distances, like more than a marathon, these Ironman things, and he prefers to run when it's maybe 40 or 50 degrees, which feels cool to the rest of us, almost uncomfortably so.
Right.
But if you're going 50 miles or more...
Nope. You thought it was no, not at all. Yeah, I know. I woke up and I was like, 50 degrees. Walking to class at 8 degrees. Oh, I went to that. There's my hot water there. And I walked over to get hot water. And I was like, I hope it warmed up against a couple degrees. Yeah. I actually have to walk a significant distance because it's cold. I know. They don't have any class. I didn't have class yesterday. Yeah, and I was definitely
Good morning, Gabby. How are you?
I'm good. Last night I had a dream that I had a presentation today.
Okay.
And I was trying to make my PowerPoint for it during the
Well, how did you do? Did you do okay in your dream?
I don't know what happened.
You don't know what happened?
It was very scary.
Well, I bet it went really well.
Thank you.
Hi, Shelby. How are things?
Good.
Okay, good. Good morning, Gwen. Good morning, Vanessa.
I feel like I don't know what, I feel like I'm definitely going to be very scary, and I probably shouldn't do it tonight, but maybe next week I'll start. Say Wednesday, but...
Good morning, Karen. How are you? All right, thanks. Good morning, Victoria.
Already fixed the camera. I know it's a little ahead of schedule.
But then I have 10 o'clock. You guys are ready to like 10 o'clock or just like have working at 11:30 like right after that.
15 minutes was an hour.
Yeah. And then I like
I just feel it's on the fourth.
class. And then I'm about running.
That's a good point.
Not challenge maybe.
Good morning, Hannah.
After lifting, you won't have time to shout or get lunch.
Yeah. So if I just go to like 10 o'clock. So
This makes me mad that lifting
it's just like right in the middle of my day. Like with the day at 11:30.
I just meant in general, like last night.
Oh yeah.
Like it's almost 8 o'clock. So it's long. Yeah.
I went to work got out of practice at 7:40. So they just got a practice like extremely late.
Okay. I just want to. I don't know.
Okay, we've got 8:30, so why don't we get started? Good morning, Psych Stats.
Good morning.
Happy Wednesday. Hey, great news. Quiz tomorrow. Yay. And the quiz is at 8 a.m., not 8:30. Yay. Let's give it up for the 8 a.m. quiz. Yeah, right, all right. And then what kinds of things happen this Friday? Sorry, what is it?
Lots of exams.
Lots of exams, okay? Okay, and this particular one will be our exam 1, right? So you've already got that prompt, and I'm sure people have been plugging away on that. We look forward to having our writing workshop on that day. So we'll probably handle that in the back table, and we'll pass around copies of our work and just give some feedback to each other on that. It should be, I think, really informative. And you'll also hand in a copy electronically before you come into class. Okay, so we have our computer quiz, and then we have the writing workshop, which is exam 1. It's an experiment this year where we're trying to do our exams in this way where you're not so time pressured, right? You can take the entire week to write it out and really get some good thoughts down, and then also get some feedback on your writing. So looking forward to all of that. Okay, so we're going to spend most of today preparing for tomorrow's tomorrow's computer quiz, and just to remind you something we've already seen a couple of times, I think. We'll go to here, and this is the detail on the computer quiz that's available to you on Blackboard and also on the S drive. These are always low stakes. This is only 5% of the grade, which is 1/32 of the GPA. That won't matter when you're 25, okay? But it is important that we develop some skills. So you'll have the entire period for this. We'll have some Excel things to do, and we'll practice some of that today. We'll have some SPSS things to do today. And you can see on this slide that we've already done many of these things, and we'll have a few more of them to do today. So here's a list of many of the things we've done in Excel. Lots of different commands. We've manually computed SDs and variances and so forth, and we want to make sure that you get all of that so that when we have a more complicated kind of computation later on in the semester, you feel very comfortable with the basics there. So today we'll be doing 95 and 99% confidence intervals. I think today we will not be manually computing in Excel the chi-square statistic. I think we've got enough on our plate, but we will do that in SPSS today. We've already done things in SPSS like generating all these different kinds of descriptive statistics, selecting cases, recoding cases, computing new variables, and today we'll do some chi-squared work. And I think that should be plenty. We do have to limit what we do tomorrow, what we test you on, because you only have 50 minutes, and yet we've been going already for almost 3 weeks. Right? So we have lots to do. And only a limited amount of time for testing. Okay? So that's available to you out on the S drive and Blackboard, so that's always clear. Okay? Any questions on where we're going for the next couple of days? Okay, why don't we do this? Why don't we start it out in Excel, because that's actually where we left off on Friday. Of course, on Monday, we had our journal club, and we had a terrific conversation about chi-square Cosmo, and Sarah gave us a wonderful presentation. But last time we were in this format, we were doing some work in Excel. So can you just open up a blank Excel? Because I think there'll be an example like this tomorrow on the quiz. And we'll do some exercises, some of which will be familiar, some of which will be not so familiar. So when you have a blank Excel sheet up, can you just raise your hand so I can see that we're all there? Just click on Excel and open to the blank one. Okay, so what we're going to do is we'll generate some dummy data, and then we'll graph those data. And then maybe we'll generate some error bars, and then we'll turn the error bars into 95% confidence intervals. Along the way, we'll add some bells and whistles to our graphs so that we can make them presentation quality. Okay? All right, so why don't we go ahead and pretend that we've got hypothetical, say, 4 groups, and we're going to put in some data on these 4 groups that might range between 0 and 10. So I'll do this with you. I hope you'll play along right on your computers. And why don't we go to something like cell B2, and we're going to have 4 groups. We'll simply call them group 1, 2, 3, and 4. Okay. And interestingly, in Excel, if you put in group 1, you can actually drag using that lower right-hand knob over, and Excel figures out what you're trying to do, that you might be adding other groups. So we'll see. Did anybody get that to work? Groups 1, 2, 3, and 4. And you could type it in manually, but sometimes when you're on a computer quiz, you're mindful of the time, and you want to make the best use of your time. Okay, why don't we do something like assume that we have maybe 10 people per group. So over here, what I'm going to do is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that we have a label for each person in the group, or at least an ID number. And here's an interesting trick that I use sometimes. Let's put in the number 1 in cell A3. Right? That row will correspond to our first participant in group 1, 2, 3, and 4. So far, so good? Okay. What we can do is sometimes in my studies and maybe in the studies that you will be running, you're going to have a lot of participants. So if you wanted to manually number them, you'd have to go 1, 2, 3, 4. You have to put in a lot of numbers. You can take care of this by way of a computation by simply saying, I'm going to make this cell equal to the cell above that plus 1. So I'm now in cell A4. I'll say it's equal to, and I'm going to click on my neighbor up top, and you can see that I'm referring to cell A3. Okay? So it equals A3 plus 1. And I'll leave that right there. Okay? So this particular cell, which is itself A4, is equal to my upstairs neighbor plus 1. Who's with me on that computation? Okay, all we'll do is, and then we'll hit enter. And what do you know? Excel can come up with 1 plus 1 essentially is 2, right? Now what we'll do is we'll grab the right-hand side here, a little knob, and we'll drag down until we get to a total of 10. And that took a little bit longer than it might have taken you had you done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you can imagine that you might have data sets in your life that are going to be several hundred or several thousand persons long. And it's just easier to put in that one computation, drag it down, and it's perfect. Right? If I have to put it in manually, if I'm the one doing the data entry, I would make a lot of errors. Maybe your data entry is better than mine, but mine is not that good, really. So whenever I can save myself from myself, I try to do it with a formula. Okay? Who's all right with all of that? Okay? Before we go too much further, can we just get a little bit of practice saving our files today out to the assignment inbox? Because what I'll try to do tomorrow is I will hand you a sheet that has questions on it that I want you to answer. But ideally, you wouldn't have to make answers right on there. You're going to be making electronic answers for the computer quiz. And I need to see your work by having you save it out to your assignment inbox. So I think we've done this once before, but just to make sure, we can go File and Save As. And we can click on Browse, which is down here on this side. Okay? And down here, it highlights a file name for you, and you can call it anything you want. You can call it today's practice, or you can call it practice for quiz, or you can leave it at book 1. Right? But what you do want to make sure is true on your menu is that you've navigated out to the S drive, you've gone to Matthew's N, in our course, which is 370, and you've gone to your assignment inbox, and here yours looks different from mine because I have one for every one of you, and you would only have the one that corresponds to your name. So if you can click into your particular assignment inbox, and this way, just in case we get a little power hit, every once in a while in Granville we do get a power hit, and it's nice to save your work every few minutes so that if we do lose some power and we have to restart, you don't go all the way back to square one. You go back to just the couple of minutes that you might have been working since the power loss. Who's okay with that? People all saved to the assignment inbox. How you doing, Vanessa? Did that work? Or okay, we don't have an assignment inbox for you. Okay, we want to make sure that you are in. Okay, you want to be on the S drive.
It won't show it.
Okay, you don't have an S drive. Okay, why don't we do it this way? Can we save it first at the desktop?
Mm-hmm. Okay.
And you can name that anything. Is book 1 okay, or do you want?
Yeah, that's
okay.
fine.
Okay. Let's see. Okay, let's just do that for now. We can figure out how to. Have you typically been able to get out to the?
Yeah.
All right.
The first time we've had.
Okay, thanks. We might have you sign on. When we're doing SPSS in about 20 minutes or so, we might have you change to a new computer. Okay, that's fine. All right, everybody's got that going? All right. So I'm going to cancel out of that. And we have this structure. How many people have that much of a structure? Okay. So why don't we pretend that we've got some scores here on some dependent variable. These could be mood scores, these could be reaction times, they could be anything we want. I like to sometimes create a phony name that doesn't really mean anything because that would seem a little bit abstract, and we want this to be a technique that we can use for anything. So imagine that there's a variable called schligs, and schligs ranges between 0 and 10. Does anybody remember the command for generating random integers between 0 and 10? Yell it out if you remember how we might do that. I'll give you a hint. We start out with the equals sign. Yeah, go ahead, Karen.
Rand between.
Okay, so rand between. And we open a left paren. We always give some command name left parenthesis, and then we stick in so-called parameters. What are the parameters here, Karen? 0 and 10. And typically we separate the parameters by a comma. And Excel always prompts you, give me the bottom of your range, comma, give me the top of your range, right? So we're going to put 0, 10. Okay? Right paren, I'll leave that just like that. You can hit go, you can hit enter, and hopefully you'll get a number between 0 and 10. How many people have that? Okay? Another little trick, you will not be graded on this, but it just helps me when I'm creating these things in Excel, if I can center it. So I'm going to highlight all this stuff, and I'm going to click on the center bit, which is right over here. Okay? Maybe you're familiar with that inside of many of the Microsoft products have that. Okay, so we have this, and we can simply copy that formula by dragging it down and dragging it over. Okay? And as you hit the F9 key, you'll see that you get random numbers in between 0 and 10. We could have made that a different range, but our fun variable for this morning is schligs, and it happens to range between 0 and 10. Who's okay with that? Does that work? Okay. All right, now what I'd like to do is, let's pretend that's the raw data. We're going to now start creating something of a summary where we're going to get some measures of central tendency and dispersion. We'll even work our way up to a 95% confidence interval. So to begin this summary table, why don't we copy one more time? I'm going to highlight these four. I'll do a Control-C. I get the ring around the rosy, okay, indicating that Excel recognizes I'm trying to copy something. I'll come down to maybe B14 or just one or two rows below the bottom of my raw data. I'll do a Control-V as in victory, and I get group 4 there. Groups 1 through 4, excuse me. Okay. How many people have that? Okay. And why don't we start creating now a summary by saying that we're going to take a row that has the means in it. Beneath that, we might have a row that has the SD in it. Is there a fancy version of an SD that might pertain to the distribution of means? Can we yell out, what's that fancy kind of standard deviation called? Standard error. Okay, why don't we put in an SE? Okay. And then why don't we say this? Why don't we also, we'll build up to a 95% CI, or confidence interval. You've already answered many TED Ed questions on that. Right? And why don't we be wild this morning and do a 99% confidence interval also? So we're just going to get some summary data for these 4 groups, for the moment randomly generated numbers, and we'll get this on the Schligg's variable, okay? So you tell me, how can I begin to get the mean using an Excel command? Yell it out, please. The command is equals average, okay? If you put in mean, interestingly, it won't work. It has to be an average, so I'm going to get an average, and I'm going to highlight those. Your numbers will not look like mine, and why is that? They're random numbers, okay? So I'm going to highlight this subset that we're working on here. We're putting together some data and some summaries, and I want that to look nice and centered, so I've got the centering going there. How many people have the means created? Okay. Now for tomorrow, we might have you do an exercise where you're actually computing these standard deviation manually. Who remembers doing that? We had a score of raw means, and then raw scores, and then that whole row was like that, and the whole column was like that. Then we did the deviations, the squared deviations. We summed the squared deviations, and then we divided by different kinds of numbers, n or n minus 1, depending on whether we wanted a variance for the population, for the sample, and so forth. Then we took the square root of that. One of our mantras was that the standard deviation is the square root of the variance. Okay? But we also learned a command. Can anybody recall what the command was for standard deviation? Yell it out if you remember what it was. STDEV, right? Okay. And we want, for example, the standard deviation for group 1. So we're going to highlight over the group 1 values. And then we can slide that over. Okay? How many people have that standard deviations going? Okay, so we've now used that command. Okay, somebody remind us computationally, how do we get, we've already talked about conceptually what the standard error is. Computationally, how do we get the standard error? Thanks, Molly.
The standard deviation divided by the square root of...
Divided by the square root of n, right? And that's going to be the square root of n, not n minus 1. So that's spot on. Thank you, Molly. So it's going to be equal to my neighbor upstairs. I've already done the standard deviation, right? So I've already got that. And I divide by the square root of n. Can somebody help us out with Excel's square root command? Yell it out if you know it. So we're not going to put in equals here. We'll start out with, what is the square root command? SQRT. We open a left paren. Okay. And we put in what number? 10. And that's exactly right. And that number is, where did that come from? We happen to have 10 people here, right? Okay, so we can do it just like that, square root of 10. And then I'll pull that over, and now I have mean, standard deviation, standard errors for all of these. And every time we hit an F9, we get a new set of numbers, but we have everything built in these spatial relationships. Who's following all that? Okay? All right, I hope this won't confuse you. Tomorrow on the test, you can feel free to use the square root of 10 or whatever number we might have on the test if you're doing something like this. Maybe it'll be 20 people that we have or whatever that number. You can put in a literal value here. Okay? There's another way of doing this. Okay? There's another way of doing that. And you can take advantage of something in Excel called the count command. And the count command counts how many values you have in the range that you specify. Okay? So if you're cursoring over 10, it would tell you that there's going to be a 10 there. So right now where we have a particular 10, we're going to, for the first time this semester, use a so-called nested function, not to be confused with a nestor function. This is a nested function, an embedded function, a composite function. Okay? So can we all go to cell, for me it's B17, and we have the upstairs neighbor divided by square root of 10. Can we all highlight the 10? So I've just highlighted over the 10 there by putting my cell right there. How many people have got that? Okay, I think we're all there. Okay, can we now, right, instead of where we had a 10, we're going to insert a command, which is the count command, C-O-U-N-T. We open a left paren, and why don't we open a right paren also? Okay, so that we have the total number of parentheses is correct. And what we can do now is we can say, Excel, please count how many values we have between yo and yay, okay, between here and there. And it will figure out that there are 10 in there. So we're taking the square root of the, square root of the count. Okay. And that works too. We'll see if I lost anybody on that. How many people got that? So you don't have to do it that way. Tomorrow you would get full credit for doing either of those, but I can assure you, once you really get into running your own studies and you've got spreadsheets filled with data, sometimes you will know off the top of your head, I had 35 people in this condition. Other times you'll have no clue how many, or there are variable numbers, and it's just easier to highlight the whole thing and let Excel do the counting for you. Sometimes you'll have a missing cell. Okay, so now you say, well, I had 35, but this person dropped out of the fourth condition, and 2 people dropped out of the fifth. Just highlight over the whole thing. Let Excel do the counting. That way, it won't make an error. Okay, so we have all of that. All right. Now, you might remember from a few TED Ed lessons ago how we convert from a standard error to a 95% confidence interval. Does anybody remember how we do that? It's been a little while. I'm going to call up something that might help us. I'll call up a wiki on z-scores. And here's one of our favorite pictures. We've done this picture a few times. Who remember seeing this picture? Okay. So if I go plus or minus 1 standard error, I'm basically giving you the 68th confidence interval, the 68% confidence interval. And can somebody remind us where that number came from? 68%. Thank you, Gabby.
It's 34.
Right. So here I have my error bar, if you will, horizontally displaced. Right. Here's the mean. I'm going horizontally to the right, horizontally to the left. It's almost like my error bar is going this way. On our graphs, we typically draw the mean upward, and we put a vertical error bar on it. So if I go up by 1 standard error and down by 1 standard error, I'm going up by 34%, down by 34% on this, and 34 and 34 make 68. So we can say that we're 68% confident that the mean is somewhere in there if we use plus minus 1 SC. Who's following that intuitively? Okay? But we could have used something else. I could have, instead of going out by 1, I could go out by 2. So I could multiply my standard error by 2, and that would give me now something like, like the 97.7% confidence interval, right? If that works, right? Or whatever those numbers are, 34 and 34, 68, and we would add to that another 14-ish on each side, okay? And that would give us the next level of confidence, okay? So a couple of numbers I'd like you to memorize, and maybe you already memorized this. Anybody remember this number, 1.96? Does that look familiar? Okay. We mentioned it only in passing one time. The other one is 2.58. These are numbers I'd like you... They'll be very important numbers in your career if you do anything statistically. Okay. This number is essentially the scaling factor to get to the 95% confidence interval. 95% CI. And what that means is, instead of going up by 1 or down by 1, if I go up by 1.96, that would actually put me out far enough that inside of that, I've got 95% of the full range of the Gaussian distribution. Here I only have 68%. I could pick some other number that would give me 80%. I could pick some other number that would give me 83%. The magic number that corresponds to 95% happens to be 1.96 z-scores. Okay? So if I go up by 1.96, down by 1.96, I'm accounting for 95% of that area. The other magic number is 2.58. This would correspond to, you tell me? 99% confidence, right? And these are roughly analogous to the 0.05 alpha level and the 0.01 alpha level. People seeing where those come from? Yeah, okay. So those are good numbers to have in the back of have in your back pocket. They come up fairly frequently when psychological statisticians are talking about distributions that are Gaussian, and a lot of our distributions are Gaussian. So those where those numbers are coming from. Okay, so that's it conceptually. So basically we're going to take the standard error and scale it up by some factor in order to get to the 95% confidence interval. And so we can do equals my neighbor upstairs times, yell it out, 1.96. Okay. And now instead of going up or down by 1 standard error, I can go up by 1.96 standard errors, and that just happens to be the number of z-scores or standard deviations that we need to spread out in order to cover 95%. We can play the same game for the 99% bit, right? And we can say that this is equal to my neighbor 2 floors up, okay, because we're always grabbing the standard error, and we're going to multiply that by 2.56. And as many of you correctly noted, I do read your responses. I don't always provide feedback on all of your responses, but you get feedback from me on TED-Ed. People were correct in responding to a TED-Ed question from about a week ago when you were reading about the DOM and the 95% confidence interval. We can be 99% confident that the mean is going to land in this range. If we're only 95% confident, right, we'd have to have a smaller range, right? So that corresponds to these larger and smaller numbers. Okay. All right. How many people have a summary area that looks kind of like that? Mean, standard deviation. From that, we can easily derive the SE. From the SE, we can easily derive some kind of confidence interval. And the ones that we're going to focus on this semester will be the ones that the field most frequently uses. But it might be that for whatever reason you want to use some other confidence interval. You just find the equivalent scaling factor and multiply your standard error by that. Okay? Okay. Having done all of this, why don't we now begin to graph that, then we'll put some bells and whistles on the graph, then we'll, probably in 10 minutes, we'll be over in SPSS and we'll do some chi-square work. So to get a bar graph going, or a column graph, can you join me in highlighting these? We're going to first begin by graphing the means. And now that we have qualitative labels for our 4 different conditions on our x-axis, I think Excel will let us go straight into using a column graph. Sometimes if our x-axis contains numbers rather than letters, it's better to start out with a scatter plot and then change the chart type. But here, because we have this qualitative variable, I think Excel will let us get away with inserting a chart that is a column chart. So if you'll join me now in going Insert, and then we'll come over here to Charts. And there's a small icon. These are hard to see, and I apologize for that. If you look way up top, maybe you can see, you won't see it on the video, but you'll see it over here. We can click on that. Okay? I think we can take this guy, this first one here, and I get something that says Group 1, 2, 3, and 4. And if I click on the F9 key, it does a dance for us, as you might expect. How many people got that? Did I lose anybody there? Okay. All right. Real good. So let's now add some bells and whistles. Let's do one that we hadn't done before. What I would like to do is I would like to fix the y-axis, okay, on some standard value. Right now I'm defaulting to 0 to 7. If I hold down my F9 key, every once in a while it will flip to make a nice looking picture. Now I'm at 6. Now I'm at 8. Okay, so as I happen to get higher or lower values, this thing moves around. Sometimes it's nice to just freeze the extent of your ordinate, your y-axis, to some value. Does anybody know how to do that? How to freeze this over some range, maybe to 0 to 10 or 0 to 12 or something like that? A rule of thumb, as you're working in Excel with graphs, if you think that you want to work on some aspect of your graph, click on it. Okay, so if you go over here and let's try clicking on these numbers. Let's see if we can click on the numbers themselves. Okay. Do you get a format axis option if you click on that? How many people get the format axis? So you have to click right on those numbers, format axis. Is that working for you, Vanessa? Okay, good. Let's go to format axis. Okay. And over here, it shoots in from your right-hand side. You get to specify a minimum. Right now, I'm defaulting to 8. You might be defaulting to some other number. Why don't we pin the bottom of this axis at 0, which is where it is currently. Okay. And why don't we pin the top of it at, I'll use 12. Wouldn't have to be 12, but that's comfortably above the range. And then we'll say, OK, clicking over here. OK, and hopefully now, as you hold down your F9 key, you still get a dance of your data, but the y-axis is fixed. And that gives you some stability. Who's OK with that? OK? All right, now why don't we add some error bars? Why don't we add, for example, the error bar associated with these 4 groups, and why don't we go specifically with the 95% confidence interval? That would correspond, at least approximately and conceptually, to the 5% alpha level. Right? 95 and 5 are complementary. Okay? Somebody remind us how we do that? It's been a couple of days. We've done the error bars once before. Yell it out if you remember. Okay, we can go to the green plus sign. To get the green plus sign, we need to click first on the series for which we want the standard error. And once we do that, then Vanessa's correct. We do get that green plus sign. Thank you, Vanessa. Okay, so we'll click on that. Now what happens? Error bars is about half the way down here. I think we have to click it. I'm not sure if we have to click, but if you click on that arrow, okay, then we get to, you tell me which one? More options. Very good. Okay, and then we're so cool that we want custom error bars. We have to specify those values, and this guy gets to float anywhere. Put him in a place. This is a bad place to put him. Okay, right? This is another bad place to put him. This kind of works. Okay, and we'll get rid of that. I'm highlighting these and backspacing. So I've cleared that out. And now I was just waiting. How high do you want to go up? How high do you want to go down? We'll keep those symmetric. You wouldn't have to. Excel gives us some nice flexibility. So I'll just use positive first. And we said that we wanted the 95% confidence intervals, which remember we got by scaling up by not a factor of 1, which would have been the 68th percent confidence interval, but this number, one of our magic numbers, 1.96. And that now puts us to what is row 18 for me. And I'll highlight over those four. I'll do it again over here. Okay, and you can see those are pretty hefty error bars. Okay, they're pretty good size given the means that we have. And we can hold down the F9 key and get all of that. All right, how people have that? We could have highlighted over the 99%. We could have highlighted over the standard deviation, the standard error. Lots of choices when we're describing the dispersion of a data set. And here we're using the 95% confidence interval. Okay, let's do a couple of bells and whistles, and then we'll also do the if statement, and then I think we'll move on over to SPSS. So let's do the if statement first before we do the bells and whistles. How do people remember seeing the if statement here, the conditional statement, if? It's been a little while. Right? We've done the equals if, but we might not have done that since the first or second week of class early on. So just to have Excel do a little bit of decision making for us, why don't we have Excel compare the means of two groups? Not statistically, but we'll look only at the means, and we'll ask if group 1 has a mean greater than group 2, we'll have Excel do something. Like maybe say group 1 wins. Okay? We'll compare group 1 to group 4. If group 1 has a higher mean, it says group 1 wins. If group 1 doesn't have a higher mean, it says nothing. Okay? So we're going to build a little conditional statement to learn the if statement that might be really helpful later on for us. So this goes equals if, find any open cell that you like. Okay? And now we have to put in some kind of a logical test. So if we're going to do a simple test like compare just the mean of group 1 to the mean of group 4, we can say equals if, left parenthesis, and I'm going to click on the cell that contains the mean for group 1. For me, that's cell B15. How many people are following that so far? Okay. If that cell happens to be greater than, I clicked on the greater than sign, the corresponding mean for group 4, okay, so I clicked on that. So computationally, in Excel, that equals if B15 is greater than E15, then I'm going to put in a comma. And the way this always works in Excel is you have this conditional statement, however you choose to specify that. We're making this comparison here. And then if that's true, do thing 1. If that is not true, do thing 2. Okay? So thing 1 might be something like this. We want this cell to read a particular statement or put out a particular statement. And we'll put in a double quote there. And we'll say group 1 wins. I'm just making that up. You might have it do something more interesting than that. But if group 1 has a larger mean, we'll say group 1 wins. And we'll close that off with a double quote. Okay? So you're telling it to put out some verbiage. And then a comma. Whenever we have a comma, we're telling Excel we're moving on to the next parameter that Excel requires. And then if we want it to do nothing, we can do it this. We can simply put in a double quote and a double quote. So it will basically put in nothing in that cell. So if it's true, group 1 wins. If it's true, do nothing. And that's thing 1 and thing 2. Who follows the logic of that? Does that work for us? Okay. Let's see if I got, and sometimes I make a syntactic error. Let's see if that works. Okay. So I get a group 1 wins here, but then if I hit F9, every once in a while that disappears, and it reappears, and if you hold it down, it goes crazy. Okay. There'll be times when in a few weeks, when we're in very complicated computations and we want Excel to make some decisions for us. And we can have Excel make decisions just like that based on whatever condition we want and what we want it to do, if it's true or if it's false. Okay? So we've got the if statement working for us. Okay? Why don't we go back over to here? We'll add just a couple of bells and whistles. Can we click on the green tab one more? And why don't we get some axis titles? Okay? So I'll click on axis titles, and then over here I might just click on those, and we might say that this is the variable called schligs, or whatever you want to call your variable. I created a nonsense pronounceable syllable. That's my Schlig's score. And then maybe my x-axis contains group. And I have 4 groups. And it's good practice to always have a very clear label on your y-axis and a very clear label on your x-axis. Okay? A title might be something like Nestor's graph, or you can put in your name. Okay, so now the graph has a title. It's well labeled. We have means and some interesting indication of dispersion, the 95% confidence interval, because we know all about how the DOM works, and that for any Gaussian distribution, this will always be true. These numbers will always be true. And when you're collecting real data, they might not be perfectly Gaussian, but we always assume, or we often assume, that Gaussian is a reasonable approximation. Okay. Who's okay with all of that? All right. All right. All right, it's 9:03. Why don't you go ahead and save that, and just so that you make sure you've got that. And then I'm going to turn, while you're doing that, I'm going to turn this one on, and we'll get Vanessa back to a place where she can use SPSS. We're going to go to SPSS now. I'm not sure you'll get there because it doesn't look like you're talking to the network. You need to be out on the S drive. Okay. So we'll give you a moment to get out to SPSS. And for the rest of us, can we please, we can put Excel away. We're done with that. We'll go out to SPSS, and as we often do, we'll go to our GSS93 file. And we'll start working on some chi-square work. I realize this takes a moment to load. Did that one come up? Oh, it's hibernating. Okay, do you want to try another? Okay. Boy, we're just not having, poor Vanessa can't get on the network this morning through no fault of her own. Sorry about that, Vanessa. Okay, so how many people have that up? I've got GSS 93 running. Okay. Okay, I think most of you have done these 2 different varieties of chi-square. So can somebody just remind us, what are the 2 kinds of tests that we have in chi-square? Thanks, Melanie. Test for independence and goodness of fit. And I think all of you made correct responses on the question where we asked you to distinguish them one from the next. I think something that's true about all chi-squares is that we are always comparing observed values to expected values. We difference those scores. We square that difference. We sum that square difference. We've done something very conceptually similar when we did our manual computation of the SD. And when we sum up all those square differences, we say, well, did they exceed some critical value that comes from our chi-square distribution? Thank you for your draw 2 responses. Many people drew the degrees of freedom 1 chi-square distribution. That was all looking really quite good. So I was really pleased to see where people were with all of that. So why don't we go ahead and let's take a look at some of these variables, and why don't we do the simpler of the 2 first? The simpler of the 2, I think, is the goodness of fit model, because it's only looking at one particular variable. And we're going to ask, how do you classify people in that variable? Maybe across 3 levels, maybe across 4 levels. And we can ask whether the people are distributed in accordance with a particular statistical expectation, the expected values. And we might use what I sometimes call the even-Steven model. If we have 4 values, you might imagine that they each occur with a 25% probability. If you have 2 values, they occur with a 50% probability. If you have 17 variables, they occur with a probability of 1 over 17. Okay? Who's following that? Okay, so we can use an equal probabilities approach to this. Okay? And why don't we go ahead and go first to the variable view. If you have this open, realize that Vanessa's still probably catching up with us. Is it still coming up, Vanessa? It's loading? Okay, all right. Here we have the variable view. And why don't we drop down pretty far, further than we've gone into this. Can you join me in looking at variables? And hopefully, Vanessa, you can see up here also. Why don't we look at variable 67? I was just peeking through these this morning. I think that's kind of interesting. They were surveying people on basically their endorsement of evolution, how humans evolved from animals. To what extent do you believe that to be true or not true? So we're looking at variable 67, and we could look at the values that they have here. The ones that are really doing the work for us are values 1, 2, 3, and 4. Is it probably true? definitely true, probably not true, definitely not true. Those are 4 of the different values. And they have a couple of holdouts for I don't know or no answer. But we really want to know about these 4. And so we're going to take a look at those values. And it might be the case that those are equally occurring in the population as of 1993, when the sample occurred. Okay? Who's following that? Okay. We might look at another variable, too. I might look at, let's go down 1 or 2. These are really fun questions, I think. Is the greenhouse effect caused by a hole in the atmosphere? Okay, that's the question that people were asking. And let's go to their values. And I think, again, we're going to get the same kind of a layout. They're doing something like a scale that ranges from definitely true, probably not, definitely not true. They have those options. And we can, again, look at an even-Steven model. Are those 4 response options being exercised with equal probability? 25% in this case. Okay. Does anybody recall how we get the chi-square test of goodness of fit going? The 2 tests are actually very counterintuitively in different submenus. Sorry about that. I'll give you a hint. We'll be doing a statistical analysis on this. A statistical analysis. What's our first click? Analyze. Okay, always a good first start, or at least frequently a good start. Okay. Weirdly, this goes down to nonparametric tests. So chi-square is a nonparametric test. Okay. So I went analyze, and then it's a little bit further than halfway down there's nonparametric test. Who's got that? Anybody find that? Okay. And then we're going to go to legacy dialogue. Legacy dialogues. Okay. Not at all intuitive. Sorry about that. And we'll go to chi-square. So I'll let you click on this, but I'm going to leave that up just like this. Okay. So that was analyze, nonparametric test, legacy dialogues will go into the chi-square. Okay. And that should generate a submenu. How many people get the submenu? Okay, still coming up? Oh, okay. All right, good. So we'll go to chi-square, and we get some kind of a submenu. And we want a test variable that was 67 variables deep. So how many times do we have to click on the down key? 66. I'll do it out loud. You can do it with me. We'll see if we all get there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 60. 1, 2, 3, 4, 5, 6. See, did I get there? Okay, there it is. I was off by a couple. Okay. But in that small window, it says humans evolved. If it helps you, you can stretch this thing out. Stretch. There it goes. Okay. And maybe you can see that. The one that says right? Why don't we move that one over? While we're there, can we also slide just a few down from there? There was this greenhouse one. It's 1 or 2 down from where that was, so we don't have to do another 70 strokes down or 68 strokes down. We'll throw over the greenhouse effect. So we'll look at these 2 variables. We're not comparing them to each other. We're just getting some analysis on each one in isolation. How many people have moved those 2 variables over? Okay. Anybody not find them? Okay. Okay, I think we're there. Notice how Excel defaults. It defaults to all categories are equal. Okay, what we could do instead is we could pop in our manual variables. We can say that on across these 4 levels, we want to put in something like, and you don't need to do this, 0.25. Oops, excuse me. I can put in, well, I can say 0.2. And then maybe I think the next category is 0.3. And the next category again is 0.2. And then again 0.3. What you might notice about these numbers is they add up to 1. 0.2 and 0.3 add up to 0.5. 0.2 and 0.3 add up to 0.5. 0.5 and 0.5 add up to 1. So we've covered 100% of the probability here, but instead of being 25% each, I'm stacking the deck a little bit irregularly. And these numbers can come from hypotheses that you might have and so forth. But why don't we just stay with the even-Steven hypothesis today? So I will remove these guys. We'll stay with the even-Steven. That's how Excel defaults. All categories are equal, 25% each. Okay. How many people have that? How many people follow the other idea of entering alternate probabilities? Okay. All right, why don't we take a peek? We'll say, okay. And this is what we get out. Okay. We'll take a look. And it gives us some summary for the humans evolved from animals response and also from the greenhouse effect. And we're getting here the statistics associated with those. Okay? And for the one that says humans on that question, we are actually getting an asymptotic sig value. Remember that in Excel, frequently, in SPSS, when you see sig value, that's basically the p-value. Right? And we're always going to compare that to the 0.05. So it turns out that the even-Steven model is significantly rejected. Right? It turns out that we don't have an even distribution across those 4 response options for the humans evolved from animals. And similarly, for the greenhouse gas question, where we don't have an even distribution about those. So if we were to go back and take a peek, we can see that if you'll join me in just bringing our attention into the humans evolved from animals, the expected values would have been even-Steven 313 for each of those 4 different categories. But the observed values are somewhat lopsided. Sometimes they go way high, sometimes they're way lower than 313. So if we find all of those differences and square those differences, we get bigger and bigger and bigger chi-square values, and we exceed the critical value for chi-square, and we reject the null hypothesis. In these 2 cases, we have a tremendous departure from the even-Steven model, equal probability. Who's following that? How are we doing, Vanessa? Did that come up? Yeah, that worked? Okay, very good. Okay, so we've done that before. Just for kicks, why don't we stay with these 2 variables, and we have still enough time where we can comfortably do an example of the cross-tabs procedure, which is sometimes how people refer to the chi-square test of independence. Cross-tabs suggesting that we have one tab that contains the first variable and another tab that contains the second variable. Right? And we're going to look at whether those 2 variables are independent from each other. Okay, so why don't we go ahead and do that? Does anybody remember how we click on, or what we click on to get that going? We probably did it in Psych 200, but it's been a while. And we'll stay with these variables. Yeah, it's very counterintuitive. Let's go to Analyze. Okay, I might make a note of this. It's Analyze, and we still really want a non-parametric test, but we can't click on that because that's not how SPSS organized that. Sorry about that. They go to Descriptive Statistics, and under Descriptives, they give us the option for cross-tabs. So I'll leave that there. That was Analyze, Descriptives, cross-tabs. Okay? You can click on that. You will bring up a menu, and the menu will, again, allow you to slide over some variable that you want maybe in rows, a variable that you might want in columns. Okay? How do people get this menu? Okay? And again, just because we have to go down so deeply into this list, I'm going to stretch it out a little bit. And I'm going to go down 67 times to get to our 68th variable, and then 2 more to get to that. I'll slide 1 into rows, 1 into columns. Okay, so you can plug along at your own pace, or you can just dial down if you think that's easier. Here's humans. Okay, I'm going to slide that one into my rows. And just beneath that, we have the greenhouse question. Okay. Let people catch up with that. How many people have that? Yeah? Okay. How many people remember doing something like this in Psych 200? It's been a while. Okay. Okay. Very good. Why don't we take a look at the statistics? Why don't we take just one statistic for the moment? We'll take the chi-square statistic. I'm deliberately refraining from clicking on the phi and Kramer's phi. We'll be coming back to that, but I wanted to spend more time on that when we're talking about effect sizes. So we'll just get the chi-square statistic here, and we'll say continue. And then before we say OK, why don't we go to something like the cells, and we'll get the observed values. We can get the expected values, so we can see that we actually had 100 people in this category, but we were expecting 75. Right? Why don't we also take the percentages? Sometimes it's helpful to see in this row we were expecting 17% of the population or 17% of our sample. I think that's enough. Probably observed and expected row, column, total. We'll say continue. We'll say OK. Let me get our final output for the day. Okay. So critically, if I can ask you to drop all the way down, and let me just, before I jump into that, let me see how many people generated that output. Okay. So here's a lot of the detail. And there are times when you want excruciating levels of detail because you want to report a particular combination of a row and a column. Other times, though, what you're really just looking for is our old friend Carl Pearson. He's given us this particular number of degrees of freedom and the value that we observe, and he gives us a sig value. We typically will go with the Pearson chi-square, and that, again, is less than 0.05, so we would reject the null hypothesis that these two are independent of each other. Right? That these two are independent of each other. That's really what we're testing in the chi-square test of independence, is variable A independent of variable B. And here we have evidence that we can reject that null hypothesis. And then if you wanted to figure out, gee, where are we finding the mismatches, we can go back in and we can look at how the rows, which correspond to humans evolved from animals, are overlapping with the columns, the greenhouse effect. And we can see that in certain cases we have overages, in other cases we're going to have underages. Okay. Who's all right with all of that? Okay. So just a little confusing there, given SPSS's choice of menus. To get to the chi-square test of independence, we had to go analyze, always a good start, and then we went to descriptives, and then we went over to crosstabs. When we did the equivalent, that just for one variable, which was the chi-square test of goodness of fit, we went to analyze all the way down to nonparametrics. Then we had to go through legacy, and then we went to chi-square. Okay, we'll pop those in. All right. So we know how to select cases and recode cases and compute new cases in SPSS. We know how to do some chi-square analyses. We know how to generate all different kinds of skewness and kurtosis and percentile ranks. Right? We can do all that under, again, the descriptives menu. To give you a little summary of what we've done so far in SPSS. And over in Excel, we learned a lot of different things. We learned how to manually compute standard deviations, how to use an Excel command to get a standard deviation and a standard error. We know conceptually what that is, because it's related to the distribution of means. And given that the distribution of means is Gaussian distributed, we can take advantage of what is known mathematically about the Gaussian, just like the Pythagorean theorem always has. If you've got a right triangle, certain mathematical truths pertain to that right triangle. If you've got a Gaussian distribution, certain mathematical truths pertain to that Gaussian distribution, and we can take advantage of particular numbers that are meaningful to our field. 95% composite equals 99 correspond to these numbers. We can generate error bars on that. We can add a few bells and whistles like fixing the y-axis, and we can use Excel to make some decisions for us using the if statement. All right. Okay, great session. I look forward to tomorrow's quiz, and then we have a writing workshop on Friday. Hope you have a great day. It's a beautiful, sunshiny day out there. And I look forward to seeing you tomorrow and some of you later today. If you want to save this to your assignment inbox, that's okay too. You don't have to. I'm not going to be grading you on that. But you can also save your SPSS output, and I'll ask you to do that tomorrow, your SPSS output to your assignment inbox. Okay.